So hey guys, welcome back to our new video. From this video, we are going to start our journey of Verilog from basic to advanced. In this playlist, we will cover all the things necessary to learn regarding Verilog. Okay, so it is just an introduction video from chapter 1. We will start our Verilog journey from next video, that is chapter 2. So in this video, we will discuss what we are going to learn about Verilog in this playlist and what is Verilog, what prerequisites you need to have, how to start. So first is what is Verilog. Okay, so the first is what is Verilog. So if you started this journey of Verilog, that means you want to go in the domain of VLSI. Am I correct? Then the first thing you need to clear in your mind is that Verilog is not a software language. When I refer to software language, any software language, I am referring to C++, it may be C, it may be Python, and so on. There are many. So, what is Verilog then? Is a hardware descriptive language. So now you will say, hey Pratik, so what is the difference between software language and hardware descriptive language? What do you mean? Aren't they same? So the main difference you can think of it is like, and you should think of this like this only from now onwards, that hardware descriptive language, as the name suggests, we describe how the hardware should behave. We are not making a software like app or website. We are building a real hardware. We are describing how the hardware should work. Like you have learned digital electronics. I hope you have learned digital electronics if you have started learning Verilog. So in digital electronics, there are different ICs which we call as integrated circuits. They perform some tasks. Like there is inverter IC, then there is many ICs. Okay, so each IC performs something, and by using such ICs, different ICs, we make one application or a hardware. So this behavior of IC is nothing but its description of how it should work. It is the structure programmed using Verilog or any software hardware descriptive language. It may be Verilog, it may be system Verilog. So we program the ICs to run such ways. Just like how using C++, C, Python, we program our software, our website to work in such manners. Similar to that, we are programming our ICs, our hardwares to work such thing. So another main difference between them is that software language runs sequentially. If you have learned C++, if you have learned Python, you would already know what I mean. If not, I will tell you that if you write a 10-line code, so how in software language it goes like sequentially. 1, 2, 3. If this executes, then this executes, then this executes, and then this executes. But on the other hand, in hardware descriptive language, the lines run parallelly. Okay, so when this is executing, this is also executing. If this is both are executing, then this is also executing. Okay, so they don't depend on one another to complete. So this is the main difference between HDL and software language. You need to keep this in mind. So I will show you in VS Code how this differs. We will write one code in this video so that we will be familiar with Verilog, the complete setup. So if you haven't watched our earlier video about installation process of Verilog with the help of VS Code, Icarus, GTK Web, you should watch it. The link will be in the description. So as we discussed in this video, we are going to use VS Code, Icarus, and GTK Web. So what is VS Code, Icarus, GTK Web? We have already discussed in the installation video. So please do watch that video and I won't repeat these things in this video again to make it concise related to Verilog. So now we will open our VS Studio Code and we will move further. So okay, so we have already discussed about the files we need to have in VS Code, the files we will make in VS Code, the extensions we need, etc. in our earlier video. So I will just recap you that there are three types of files: .v, .out and .vcd. Okay, I am repeating these things because these things are very important. The .v is the thing which we will use to write our code. It will be module, it will be for the Testbench, etc. And .out is our output file. The output which will be generated after simulation of our code will be contained in the .out file. Okay, this file is not readable to us, only this file is readable to us, that is the .v file. Okay, and .vcd is also not readable to us, it is for simulation purposes. Okay, so now we will start writing our first Verilog code to make you familiar with Verilog. So the first thing we do is say module. So as the syntax shown, we will write our module name. Let it be first module. You shouldn't give names like this. We should give the name like, if now we are going to design adder, so we'll like adder. You don't need to focus on the code right now. I am just writing the code to make you feel comfortable with Verilog. So it will be, we are just declaring inputs. A, I will just copy this line and B, just copy this line out. Sum, let it be 5x. You won't understand, you may understand some things, but it will be all clear again. So now I will just use assign sum is equal to A plus B. Okay, so this will provide our output, and this is our output port, and these both are our input ports. Okay, input ports. So now when I refer to execution of our codes simultaneously, sequentially, what I refer to is that, so now if say we have another ports, Control Shift, so I will just duplicate this and I will name this C, okay, and D. And I want another sum, let's say sum 2, okay, and I will just use this sum 2 at C and D. So what does this mean? So what does this mean is that in Verilog, the code will not wait for these to execute. They both will run at the same time. The both lines will execute at the same time. That means when we get A plus B, we will get C plus D. You will say that in C or Python, the output was coming like this. No, they weren't coming like this. When when the output of A plus B was being displayed, then only C plus D was being displayed. The speed of C++ Python is faster, so you would think that they are coming at the same time. But no, they aren't. But in Verilog, when the sum executes at the same time, sum 2 will execute. This is the main difference between software language programming and hardware descriptive language programming. And you need to keep this in mind. Okay, so this is our first beginner level code, which we will continue in our next session. So basic, where Verilog is used, we use it in digital IC design, FPGA or VLSI. So we are currently focusing on this part. We are focusing on this. Okay, we are focusing on this VLSI part, and the next is hardware verification. We will make a separate video on this if you want. What are the roles even in the field of VLSI? So basically there are many roles. First is the front end, then there is a back end. So when you are in front end, you need to design as well as verify. Okay, so you need to design as well as verify the code, the RTL code we want. So now, as the name has come, we will discuss about this also. So we will discuss about RTL. So RTL stands for register transfer logic. Okay, so basically in our whole playlist in the field of VLSI, what we are going to do is RTL. That means transferring our data from one register to another register, how the data will be transferred, what will be the logic of the data transfer between the registers. So those who don't know what is a register, so for them I want to tell you that there are different memory locations which are called as registers. This will be register 1, this will be register 2, this will be register 3, and so on. Okay, so what these registers, they store data and they transfer data based on our needs. So the logic how the data is transferred is designed using Verilog. Understood? So why we need Verilog? There are many memory locations in our CPU. There are many memory locations, and each memory location contains some data X, data N, data Y, and we want to access the data and we want to add. So in our earlier code we say A and B, so we wanted to add the data of X and Y and store it into another memory location, and how we want to access the data and what operations we want to perform to store the data was addition. Okay, it was addition, and then we store the data. This is all register transfer logic you have discussed in digital electronics. So we are basically working on the ground level. We are not working in the software domain. We are not making websites. We are not making the screen or the things which are displayed to the user. There are many architectures like ASIC, FPGA, etc. So we are going to discuss these architectures later on. We are going to make a dedicated video on the architectures. So you just need to keep in mind what is Verilog. Verilog is a hardware descriptive language. It is not a software language. Here the code executes parallelly and they do not depend on each other to execute. The Verilog is basically used for RTL designing, that is register transfer logic designing. What are registers? Registers are a block in the memory which stores data, and we write the logic using Verilog, how the data is to be transferred, how the data is to be manipulated, how the data is to be accessed. Okay, so this is all about Verilog. So we design the simulation flow, we write the Verilog code. Okay, so we write the Verilog code, then we simulate it, and then based on the timestamp we're going to discuss this. So in Verilog, time is the key. There are separate subjects on clock design, on HDL, etc, etc. So we are going to learn this also in our upcoming videos. We are going to visualize our waveforms using GTK wave. What does the waveforms mean? How you can debug our waveform? How you can check if our code has errors or not using the waveforms. So it all comes in the debugging parts which we discussed earlier. Okay, it comes in the hardware verification part. Okay, so now we will conclude our video by learning these things, what is design and what is Testbench. Okay, so there are two types of files, design files and Testbench files. So we have already seen this file. I will show you where we have seen these files. So we have seen these files here in module V and Testbench V. So module V is our design file. So I will write it here. It is our design file. And this is our Testbench file. Okay. So you will say, Pratik, so what is the difference between them? So the main difference between the design file and Testbench file is that the design file we describe the actual hardware logic. So this is the important word, so I have written it in double quotes. It is used to design the actual hardware logic. Like we want to design an adder. Earlier we wanted to design an adder. So we wrote the logic that we need two inputs, say A and B, and then we need output sum, and what we want to perform on them, we want to perform sum of A plus B. So this is the actual hardware logic, what our hardware is going to perform. Okay, and then what is Testbench? In simpler terms, it means that in the Testbench file we are going to provide inputs to our model. Just like the name suggests, Testbench, we are going to test our design file based on different inputs and check if our design file provides the accurate or desired output even under different inputs. But it is not that hard. Design file is used for writing our hardware logic, and the test bench file is used to write the inputs for our hardware logic to test it. And all the simulation time, that means after how much time one input should go, after how much time another input should go, is all written in our test bench file. Okay, that's it for our video, guys. This is all about the introduction about Verilog fundamentals. Hope you like this video. Hope you like the teaching style. As me and my team know that there is not much content on YouTube regarding Verilog and VLSI. So we are trying to cover all the concepts related to VLSI so that you don't need to purchase any courses which even do not teach you anything. Even I have learned from courses. I have purchased many courses online, and all of them were not that useful. It was all repetitive stuff which you can learn freely from any sources or books. Okay, so thank you guys for watching this video. See you in our next video. Till then, bye bye.